Hello students, today we are going to discuss very important topic, that is intermediates in organic chemistry. We know organic reaction takes place by different mechanism, but it is observed nature of reaction, it depends upon the nature of product, nature of reactant taken. On the basis of the nature of reactions, some reactions takes place in one step or in several steps. If the reaction proceeds in several steps, it must proceed through intermediates. Intermediates are short life species produced during the progress of reactions. These are short life species, reactive species produced during the progress of reaction. And as the reactivity is more, as they are very short life, they are being used of during the reaction in different steps. What are the intermediates? The intermediates are several types. It depends upon the nature of the species. Almost all intermediates are either electron rich species or electron deficient species. And there are also two types. They behave as electrophiles or they behave as nucleophiles. What are the different types of intermediates? Let us discuss. These are short life species produced during the reactions, during the progress of reaction, and during the reaction it is being used of during the progress of reaction and forming the product. And these are very reactive intermediates. And then what are these? These are types. If you write the types of intermediates, it may be carbonium or carbocation, that is carrying carbon carrying plus charge mainly. Then carbanium, carbon carrying minus charge, that is carbanium. Then free radicals, these are carbon having unpaired electrons. Carbene, that is carbon having two electrons. Carbon having two electrons, it may be in pair form or unpaired form, two electrons, that is carbene. Nitrene means nitrogen and single bond having two pair of electrons, these are called nitrenes. Benzene intermediates, these are the type of species. This is benzene. This benzene intermediates, nitrene and carbene, free radicals, carbanion and carbonium. So these are the different types of intermediates. So let us discuss one by one. Mainly we will discuss on today. We will discuss these three types of intermediates: carbonium, carbanion, and free radical. This is very important for your examination. Okay, so complete. We will write it. In case of carbonium generally carbon carrying positive charge. Carbon carrying positive charge, that is called carbonium ion, and this carbonium ion, it has 3 bonds and carrying central carbon atom carrying positive charge. That's why it is sp2 hybridization and planar shape. Types, if you see, that is generally carbonium 3 types, that is general this type 0 degree, carbocation, then primary carbocation, secondary carbocation, tertiary carbocation. Generally in aliphatic compound it is mainly three types of carbocation. 0 degree, 1 degree, 2 degree, 3 degree. 3 degree means tertiary, 2 degree means secondary. Means here the carbon carrying positive charge attached to 2 carbon atom directly. That's why it is called secondary. Tertiary means the carbon carrying positive charge attached to 3 carbon directly. That is tertiary. So it has no carbon, that's why 0 degree, 1 degree, 2 degree, 3 degree. Besides this, carbonium may be aromatic compounds. If you see this type of carbocation also available, or its derivative maybe, and cyclic compound also. Different types of cyclic carbocation also exist. These are alicyclic carbocations. So different types of carbocation are possible on the basis of the structure. So these are the different types of carbocations, and regarding the structure of carbocation, planar shape and sp2 hybridization. Then if you see the stability, of carbocation, if you see, the stability order is, first one is, very important thing is this one. This is called propylium carbocation. This is highly stable due to more number of resonating structure, because pi bond conjugation is more. 1, 2, 3. Pi bond conjugation is more. That's why resonance structure is more. Stability is more. Then will come tricyclopropyl methyl carbocation, because this cyclic compound, due to that angular strain, it forms pi bond with adjacent carbon. Due to breaking of this bond like this, it forms resonance. So the bond will be open chain, then this will be double bond, then C. You see, so that it is open. This carbon remain with double bond with adjacent carbon, and this bond is breaks. Similarly, this side also possible. So like this. So this type of resonance is called dancing resonance. You can tell in this, due to angular strain of this cyclic compound, this sigma bond involves in the formation of. This is, we can say, this is one type of hyperconjugation, involvement of CC bond. CH bond can be involved or CC bond can be involved. So this is one type of hyperconjugation. This is specific, is called dancing resonance. So in this case, stability is more. Okay. So stability order will be this one. Then will come to this one, then 1, okay, then triphenyl, this carbocation, then this benzene can unite pH whole to CH plus, this one, then tertiary. This plus is more stable because by resonance, this structure due to indole effect and hyperconjugation, pH CH2, that is benzyl carbocation, then allyl CH2 double bond CH single bond CH2 plus allyl carbocation, then secondary carbocation, then primary, then methyl carbocation, then vinyl, then phenyl, then so these are the different types of carbocation and their stability. So this type of carbocations is stabilized by mainly three effects, either resonance effect or inductive effect or a hyperconjugation. For examples, I will take this one, propylium ion. If you see the structure of propylium ion carried and this is the conjugation, that's a stability more. First structure, the resonance structure of this propylium ion will be first structure, this is the cross, then this one, then like this. So different types of pi conjugation is possible, that's why stability is more. So this type of stability of carbocation is due to resonance. So if you see hyperconjugation also, you write one H, then if you see hyperconjugation, already we have done hyperconjugation. This is the structure H plus, then double bond. So similarly, how many structure is possible? Like this, already have done 9. So 9 alpha hydrogen atom. So 3 plus 3, 6, 3, 9. So 9 type of hyperconjugation is possible. No bond resonance, that's why stability also more. So by different way we can stabilize here inductive effect. For example, this effect also can be explained, stability can be explained by inductive effect. By hyperconjugation, same carbonium can be explained by hyperconjugation, it can be explained by inductive effect. Here 3 plus I effect. Methyl. That's why stability of carbocation is already we have discussed. The stability, inductive effect already discussed. This inductive effect stabilizes the carbocation. Plus I effect increases stability. So this is regarding carbocation, the shape, structure, and this. And carbocation can be formed. Formation you can discuss the formation of carbocation. Formation of carbocation. For example, if you tell CH3C that Cl, when this Cl breaks, it produces CH3 whole 3 C plus and Cl minus. So this is the formation of tertiary butyl carbocation, that is tertiary carbocation. Breaking of this bond. This bond can be broken by using particular solvent and on heating. On warming, this tertiary butyl chloride first get dissociated into carbocation, then it is involved in the further steps, either substitution reaction or elimination reaction. So we will discuss this thing later. But this formation of carbocation also done by different way. So this is about carbonium. Then let us discuss carbanion. Carbanion means carbon carrying negative charge. That means one extra lone pair remains on the carbon atoms. So it is this type of structure, that is carbanion, and generally it is 3 bonds on one lone pair. That's why it is generally sp3 hybridization and shape is pyramidal shape. Okay, so it is like this. Minus S. So this is the shape, that is pyramidal shape. AB3L system is AB3L and pyramidal shape. But it is also observed in case of the carbanion, if it is stabilized by resonance, for example, C has 2, double bond CH, single bond CH2. This one, it is also one type of carbanion because carbon carry negative charge, but it is stabilized by resonance. If the carbanion is stabilized by resonance, it is sp2 hybridization and planar set. This is very important. If the carbanion is stabilized by resonance by pi bond conjugation, so hybridization is sp2 and set will be planar. But if it is not stabilized by resonance, so the exact structure will be pyramidal set like AB3L set. So this is a very important difference between that when it will be sp3 hybridization, when it will be sp2, when it will be pyramidal, when it will be planar. So these things remember very important. Then types. Same like your carbonium, it is also that CH3 minus that 0 degree and CH3 CH2 minus that is primary 1 degree and CH3 whole 2 CH minus that is 2 degree and CH3 whole 3 C minus that is 3rd degree. So there are different types of carbanion, carbon carrying negative charge. 0 degree, 1 degree, 2 degree, 3 degree. This is the types of carbanion. Primary, secondary, tertiary, and this is it is not attached to any carbon, that's why free, that is 0 degree. That is classification is like this. So types of carbanion. Then stability is very important. I can explain the stability. Stability's main concept is R is carrying negative charge. So negative charge when it will be delocalized, when negative charge will be dispersed from the carbon atom, then stability will be more. So generally it is stabilized by SEM, by hyperconjugation, by inductive effect or by that resonance. So many concepts you can apply. For example, your stability order for this type of carbon, as carbon carrying negative charge, here it has no plus I effect. It has 1 plus I effect. It has 2 plus I effect. It has 3 plus. Plus I effect means, for example, this is 1. If you see this structure, here it is supply electron. So plus I 3 plus I effect. Both are supplying electron towards carbon. Already carbon has negative charge. Carbon already having taking the load. Already it is with load. Then there are another 3 groups again supplying the electron towards carbon. That means the electron density around carbon is more. So stability is less. So less stable. Is less stable. So plus I effect decreases, already we have discussed, plus I effect decreases the stability of carbanion, but minus I effect increases stability. For example, if you put here one Cl, suppose this is CH2, you put one Cl, this is minus I effect, then stability of this tertiary group again increases because due to minus I effect. So minus I effect, it removes electron from the carbon atom, that's why stability is more. But plus I effect increases electron density on the carbon atom, stability decreases. So this is the concept, plus I effect and minus I effect. Plus I effect decreases and minus I effect increases the stability of carbon carrying negative charge, that is carbanion. Okay. Then next part is, so we can write the stability order, that is CH3 minus more stable than CH3 CH2 minus, which is more stable than CH3 CH minus, which is more stable than CH3 O3 C minus, as they are supplying more electron towards the carbon due to plus I effect, so stability is less. So this is 0 degree, 1 degree, 2 degree and 3 degree. But when you take any aromatic system, the stability also more. If you compare, you take aromatic system. For example, if you take one aromatic carbanion, suppose let it be benzyl carbanion, it is also stabilized by resonance. So stability is more. This case, the structure will be like this. So here this pi bond conjugation is increasing. Number of pi bond conjugation is increasing. That's why stability is increased. That's why this benzyl carbanion, this is called benzyl. This benzyl carbanion is more stable than your tertiary and other due to resonance. So you have to see what type of effect is applicable to explain the stability of carbanion or carbanion, but mainly you have to see from where the charge, the negative charge or positive charge is dispersing. If the positive charge is increasing, then stability decreases. If negative charge is increasing, stability decreases. If both positive and negative charge is decreased by any way, either interdifferent or either by resonance or either by hyperconjugation, the stability will be more. Okay, so this is regarding the stability of carbanion and types of carbanion. Then next is your free radicals. Here free radicals means carbon carrying one unpaired electron. It is mainly produced by homolytic breakage. By homolytic breakage it is produced. Already we have discussed in the beginning of organic reaction mechanism, when the bond, covalent bond gets dissociated, equally the bonded pair of electrons divided between the two bonded atoms. Each atom, bonded atom, carries single electron. That's why it is called free radical or having unpaired electrons on the carbon, homolytic breakage. But carbonium and carbanium, it is produced by carbonium and carbanium produced by heterolytic breakage. This is produced by heterolytic breakage, but it is produced by homolytic breakage. And it has also shortage of electron deficient, having shortage of electrons. Free radical is a shortage of electron, because if you see the structure of this free radical, you see one unpaired electron remain on the carbon atom after formation of 3 bonds. If you see total electron, that is 7 electron. 7 electron means it has shortage of electron. So if you see the actual structure of free radical, that is sp2 hybridization, generally sp2 hybridization. It is sp2 hybridization and planar set. But deviation takes place when it is not stabilized. For example, this type of radical, if you see this one having, this is not stabilized because fluorine has no vacant orbital. That's why this cannot form pi bond with carbon. So it is generally sp3 hybridization, pyramidal set. This is the case. But when, for this example, suppose your C has 3 dot. This is sp2 hybridization. And planar. Because already we have discussed by hyperconjugation already know. Suppose this is CH2 and H, and this is for pi bond conjugation. So CH3, C double bond, CH2, then H plus. So this one result in the formation of which one? It involved in the formation of pi bond. So when it forms pi bond, it will be forms hyperconjugation. So this is regarding the stability of free radicals, either inductive effect. Also we can say it is stabilized by inductive effect. So this type of compound having sp2 hybridization. It is sp2 hybridization, and this compound is mainly involved in the formation, as it cannot form pi bond. Fluorine has no vacant orbitals, it cannot form pi bond. That's why it, and this CF bond is stronger bond, so this lone pair remain on the carbon. It is not involved in the formation of pi bond. That's why it is pyramidal cell. So this is regarding the stability of free radicals and the cell. It may be sp2 hybridization, it may be sp3 hybridization. So it depends upon the structure. But CH3, if you see CH3, this radical, it is also sp3 hybridization. Because it is not stabilized, that unpaired electron present in the carbon remains on the carbon. It is not dispersed. But in this case, it is dispersing of the charge. That's why it is involved in the formation of pi bond with the adjacent carbon atom. So it is, we can say, it is more stable. So this is regarding the stability. Next is comparison. If you see type of free radicals, it is mainly three types. Its stability is same as your carbocation, that is CH3 plus CH3 dot is less stable than CH3 CH2 dot, is less stable than CH3 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 dot, less stable than CH3 C dot. Mainly stability increases due to plus-I effect. As the plus-I effect increases, the electron deficient nature of carbon, because carbon needs another electron to satisfy octet rule. That's why it also tendency to accept electron. So CH3 having 3 plus-I effect, that's why it is more stable. So 0 degree, 1 degree, 2 degree and 3 degree order of stability. Besides this, your benzyl, like this, benzyl carbocation also stabilized by benzyl free radical, also stabilized by resonance. Same, it is stabilized by resonance. You see, the structure will be CH2, then it will be dot, then like this. So it is stabilized by which effect? It is stabilized by resonance. So this free radical is dispersing these unpaired electrons dispersed from this carbon to next carbon. So inside the ring it will be delocalized. That's why stability is more. So in this way, the stability of free radicals, carbanion and carbanion, mainly depends upon the effects. Which effect is applicable, whether inductive effect, whether resonance or hyperconjugation. Different types of effect we can use to explain the stability of this intermediate. But if it is some way to disperse the charge, either positive charge, negative charge or unpaired electrons, then stability of this intermediate will be more. And during the reactions, the nature of product also depends upon the stability of intermediate produced during the progressive reaction. So we have to explain this thing in the next class. Okay, you practice, when you remember what is the difference between carbocation, carbanion and free radical on the basis of structure, on the basis of hydrogenation and their stability. Okay, thank you all.